Hello, and welcome to the Introduction to Simulink video. So what is Simulink? It is a product bundled with MATLAB. So if you have access to MATLAB, you almost certainly have access to Simulink. It is a tool that graphically represents ordinary differential equations, or ODEs. Now it does a lot of other things as well. It's not just for solving ordinary differential equations, but for the vast majority of purposes in a control engineering course or anything like that, you will be using it for solving ODEs. And you solve it numerically. So you're not going to get an analytic function out. What you're going to get is a set of numbers. And today we're going to look at how to set it up, how to use one to solve a fairly common ordinary differential equation, and what the results look like, and how do we get them, and how do we look at them. Okay, so we're going to simulate this thing here, which is the second order system. It's mx double dot plus cx dot plus kx equals u of t. And I'm just going to be using a step input for u of t just to show you where all the inputs are and that sort of thing. But the procedure I'm going to show you is generic for most ODEs. So you're going to see a lot of the same things that I'm going to do if you have, say, a nonlinear ordinary differential equation, even a coupled one. There's a little bit of extra steps if it's coupled, but not too many. And this basic procedure will work for you. So the first step before we even get to Simulink is you want to rearrange, and I recommend you write down the equation we're doing. If you can, if possible, let's say you have a nice linear ordinary differential equation and everything is good, you want to isolate for one of the derivative terms, normally the highest derivative. So you'll see on this end here, I have x double dot, and it is isolated on one end of the equal sign. You don't really have to do that. You could do it just as the equation is written. It's just a little bit stranger, and personally I find that it's a lot easier for me to work with this isolated form. However, you might also find that unfortunately you can't do that. So for instance, if you have a nonlinear equation, you're not going to be able to do that isolation, and as a result you just have to start somewhere. But basically that x double dot is going to give us a starting point, and Simulink, you basically have to choose one block to begin with, and then once you have that block, you take everything from there. I'll be showing that procedure as we go. We also need numbers, so again, this is for numeric solutions. It is not for algebraic solutions, and so I just chose some somewhat random numbers. M is 1, c is 10, and k is 1, and then plugging them in. Here's my equation here. So x double dot is negative 10x dot minus x plus u of t. So that's what we're going to be simulating today. So I'm going to go to MATLAB now. And this is the MATLAB window. Now I'm using our 2019B. You might have, say, 2016, 2015. It doesn't really matter. They're more or less the same, especially in terms of the basic Simulink blocks. But what might be a little bit different is how you access Simulink. So what I'm going to do is I'll show you how you would do it in 2019B, and then I'll show you if you don't have it and you don't really know how to follow along with me, it turns out you just type Simulink into the MATLAB command window and it'll open. But for me, I would just click here where it says Simulink on the Home tab. And if I click there, it opens Simulink for me. But let me close that down. And again, if you can't find it or whatever it is, or you don't want to search for it, you can just type Simulink and it will open up for you. There's no difference, and this will work in just about any version of MATLAB. Now, again, you might not see exactly the same thing, but you'll see something very similar, and this allows you to create a blank model, and that's really what you want for the most part. All these other options that we have here are great, and they're more advanced. We're not going to touch them today. So I just want a blank model, and so I'm going to click on Create a Model. Now, this might take your computer a little while. I went to my other screen, so here is now my blank model. And I'm going to put it on one side of the screen because the other thing you need, so as a blank model, you just have essentially a canvas that you can draw this differential equation on. But Simulink is a block-based language. It's really good for making block diagrams. And so I need the block library. To do that, on yours, you'll have something that says library browser for sure. So you click on library browser and suddenly it opens up. And you'll see that for most academics, we have a lot of different toolboxes and that sort of thing. We're only going to use what's in here. So if I down click here, I have commonly used blocks, continuous, sources, sinks, that sort of thing. We're just using stuff in here. And one of the reasons for that is because then it doesn't matter which toolboxes you have installed. So I have all of these, but again, if you don't have anything installed, it doesn't matter. And also, you can get extremely far just using this stuff. All the other toolboxes are there when you have a specific application in mind, so we're not going to worry about that. Okay, so like we said, we're going to be starting with that x double dot, and this is the first step that is a little bit strange, and that's why what I want you to do is sort of just follow along with me and sort of accept that this is going to be a little bit strange. So I'm going to go to continuous, and if x double dot equals to something, then logically its integral would be the velocity, or the x dot. So I'm going to take in continuous blocks here, I'm going to search for the integrator, and I drag and drop it into my model. It'll ask me for the initial condition. If I click away, it just defaults it to 0. But let's say that I actually wanted to choose something there. Let me just zoom in here. And let's say that what I wanted to do was choose an initial condition, but it came up and I forgot and I clicked away. If I double click the block, and this is true for any block, what comes out here is the block parameters, and you'll see I have a huge number of options for integrators, and in fact most blocks have a large number of options. Today we're just going to go with all the defaults, and that's why I'm not touching anything. And so for my initial condition, 0 was fine. We're basically saying we're starting at 0 and going from there. So I just say OK, and everything goes back. Now I'd like to name my block just so that I know, and I like to name my blocks based on the output of the integrator. So the output here is where the signal is going to come out of, and if this is integrating x double dot, I'm going to call this x dot, and that way I know. And now that I know that x dot is coming out of here, I just build up my simulation using the blocks. So x dot was multiplied by -10. So to get that multiplication, what I use is a gain block, and that's another extremely common block. So realistically today we're going to be using only a few blocks, but you're going to be using the gain block probably more often than not, to be honest with you. It is in almost all of my Simulink diagrams. It is so common, and that's why it's in commonly used blocks. And if you sort of search for commonly used blocks, you'll see right here is the gain block. And again, I just drag and drop it in. And now it's going to say, okay, what is your gain? Now I don't want to double click it because why not? So I'm going to enter a gain of -10. I'm going to name it. So again, to get that name back, I just sort of I clicked once on the block and it came with the name. And so this is C, the damping coefficient. And I want to connect them. So x dot multiplied by -10. Now I need to get x, the position, out. So I'm sort of in a bad space in my diagram. I'm going to make it bigger. I can drag and highlight everything, and now everything is highlighted. And if I now click, I can drag them together and move them. And I want to get x out. Well, how do I get x from x dot? I integrate the signal x dot. And so I go to my continuous blocks. I take another integrator. I like to try to align my blocks if I can. And the initial condition is 0. I'm not going to touch it. But I will now call this one x, the actual position. And I'm going to integrate, so I'm just going to click and drag, and I'm going to connect here. Okay, I'm not going to connect here outside of the gain. I just want to integrate the signal x dot, so I'm doing that. And x is multiplied by the gain -1, if you remember from the equation. So again, commonly used blocks, I drag a gain in there. The gain now is -1. And I click and drag to connect it. Now you'll notice I'm not connecting these just yet. I'm going to be building all that up. So let's go back to our equation. Let's take a look at what we're trying to build. And here it is, x double dot. So this is coming into that first integrator, and that equals to what? Well, -10x dot. So I have this already, minus x. So I have this -1 times x already. I don't have u of t. So let's go ahead and make u of t. Okay. In order to get u of t, what I'm going to need is an input. And in Simulink, in the basic Simulink, what they call that is a source. So all the way down, it's alphabetical if you're wondering, and I click on sources. And this is a huge number of input sources we can use. It's going to depend on your particular application, but remember what I said was I want a step input, so we need to search for that step. And I can't see it here, so I'm going to scroll down until I find it, and here's my step input. So I'm going to click and drag that in there. And maybe we want to align it over here. It's sort of up to you. Now it's asking me for, well, when do you want your step to happen? It could be 0, it could be 10, whatever it is. Let's say we want our step to happen at time equals number 3 seconds. So I enter the number 3. And this, again, I'm going to name it u of t. It's a really good idea to name your blocks something useful so that you know what's coming out. especially in the very beginning when you drag that first block in and it's just an integrator and you sort of have to understand what's coming into it is x double dot and what's coming out of it is x dot. It's a little bit strange, so naming your blocks is really going to help you. And so now what do I do? Well, going back to my original equation, I need to add all of these things together. And I'm saying add because my gains, I made them negative already. So I'm going to have negative 10x dot plus negative x plus u of t. Sort of like how you would write a program where you have one variable plus another plus another. I'm just going to stick with summation. You might choose to have positive gains and you subtract them. It doesn't really matter. At the end of the day, numerically, you're going to get the same numbers. So I'm going to go back now to my Simulink, and I'm going to go back now to my library, and I need a summation block. I'm just going to make that a little bit bigger. And as you can imagine, the sum, plus, is a commonly used block, and here it is. And when I drag it in, my version is going to ask me, what are the ports? But I'm going to ignore that, and I'm going to show you how to do it, just in case your version of Simulink does not have that. So I will click and drag it. And why don't we align it here? And it says, what are the list of signs? And let's pretend as though you don't have that because this is a fairly new feature in Simulink. I believe 2016 probably doesn't have it. So we're not going to do that. And I'm going to double click. And it has here a list of signs. And yours will for sure have this. And so I want 3 pluses. I want to add 3 things together. So I add that third plus. And I say, OK. And Simulink has put it in a convenient place for me. I'd sort of prefer it to be up top. I'm not going to argue with Simulink. And so what am I doing? Well, I'm adding all 3 signals together, so let's go ahead and do that. There we go, 1, 2, and 3. Okay, so now what is this? What's coming out of the summation block? Well, if we go back to our original equation, and hopefully I can have it here, I have negative 10 times x dot being added to negative 1 times x, being added to u of t. Well, this is x double dot. And here's a little bit of I guess a weird part about Simulink is that if this is x double dot coming out and this is x double dot coming in, I need to now loop it around and connect them together. So let's go ahead and do that. And now I don't really like how this looks. I want it to be higher. I don't like that it's crossing wires. To do that, what I do is I click on the wire and I just move it up. Okay, and Simulink will do that all for me. Now our next step, if I were to run this simulation now, and if you're wondering, you can do that just by clicking on the run button up top. I'll talk about all the settings in just a second, but if I run it, what's going to happen is a whole lot of nothing because I have no outputs. So basically it has run the simulation for sure. It's actually done the numeric calculation, but all of the outputs have been completely just discarded and there's nothing there. So what I need is a place to store or show my outputs. And in this video, all I'm going to show you is how to do that on a scope. I'll talk a little bit about the 2 workspace block, but we're not going to use it today. So if sources were sources, then sinks are where the outputs are. And here's a scope. You almost always want to use the scope. You don't want to use the floating scope or whatever it is. The scope is perfectly acceptable. And you'll also notice there's 2 others called to file and to workspace. You'll be using these when you do your analysis. Say you want to actually store it in MATLAB and then find out what is the maximum, the minimum, do a bunch of processing, all that sort of stuff, maybe FFT it. And that's what those 2 are going to be for. If you need them, you should go and read the documentation. They're not super difficult to use, but today in the basic introduction, I'm just going to show you the scope. And logically, I'm going to click and drag like I've done for all the other boxes. And I'm just going to now minimize this and maximize this because I essentially have everything I need. It's going to ask me how many input ports do I want. I only want the 1. We're just going to take a look at one thing. And now I need to choose, well, what is my output of this system? And if I were to connect it to this wire here, what I would end up seeing is x double dot, which I don't really want. What I do want, though, I want to see x. So I'm going to move u of t. I think I aligned it in just quite the wrong place. I'm going to move my scope. And you'll notice Simulink is helping me to align things. And I'm going to take and I'm going to drag now onto the output. This is x. So this is the actual, say, position, if it's a mass spring damper, whatever it is. This is the variable that I personally in this simulation want to look at. You might want another scope and you're going to look at x double dot or x dot or whatever it happens to be, maybe even u of t. It's all up to you what you want to see, but today I just want to see this. Okay, so I'm ready to run my simulation and I can open the scope now or later. It doesn't matter. So why don't I open it now? and the scope takes a little while to load, and there it is. And now I can run it either from my Simulink diagram or here, and I'm just going to run it from my scope so it doesn't click away. So if I run it, it'll compile, it'll start running, and the scope is going to show you everything that is coming out of my simulation. And you'll notice there's a couple of things. So I have from 0 all the way up to 10. That's my stop time here is 10. This is in seconds, and this is the response of my system, for example. And now if I really want to change things and mess around with them, I don't know, why don't I make this into negative 100? I'll double click that. I'll say negative 100. I'll say OK. I'll go back to my scope and I'll run it. And again, it's going to run, and now I have this oscillatory behavior. Just if you're wondering, what happens if I make this unstable? So instability is basically when any of these two gains are positive. So if I were to click on C, for example, and I were to make it positive 10, we're going to see what Simulink does when I have an unstable system. And I'll go ahead and run that. And a number of things will happen depending on how good my computer is. And we'll see here, this is, my computer happens to be really good at dealing with instability. So it looks like there's almost nothing happening, and then we get this massive spike. But look at my numbers here. I have 10 times 10 to the power of 12, indicating that I have an instability condition. So that's what that'll look like. On some computers, or if you run it for long enough, what you'll see is that it'll come up with an error and say, hey, this is infinite. What do I do? Anything like that. So if you have an unstable system, that is what you're going to see. Okay, so that is your basic introduction to Simulink. The last thing I want to show you is what happens if you do run the simulation and the scope is closed. So if I do that, I'll make this stable again. Let's make it negative 1 just to see what happens. And now, so I run the simulation, but my scope is closed. That is not a big deal. So it goes ahead and it runs. It says ready in the bottom here. Hopefully you can see that. And now I can just double click my scope and I can take a look at the simulation. And that is your basic introduction to Simulink.